Hello, in this lecture we find out the length of line segment X. In the drawing we have a quarter circle, A or B is a quarter circle. Inside this quarter circle we have a semicircle, this is a semicircle. And we know that side AO equals to 10 units in its length. And our mission is to find out the length of this line segment AM, that is equal to X. Okay, so first of all, because of the fact that AOB is a quarter circle, it means that this angle is a right angle. It is equal to 90 degrees in its size. And also, side AO must be equal to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore OB must be also equal to 10 units in its length. But OB is the diameter of the semicircle. And we know that the diameter OB equals to 10, therefore the radius of this quarter circle must be equal to 10 over 2, that is 5. We define the center of the semicircle as P, so the radius OP equals to 5 units in its length, and the radius PB it is also equals to 5 units in its length. We define the point of tendency of tangent AM if this semicircle is Q. We join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle, that is equal to 5 units. And we have here the radius PQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent AM. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Okay. We will focus on the common external point, point A. In relation to this semicircle, point A is the external point, because point A is not located inside the semicircle nor on the semicircle. Therefore, point A is an external point in relation to this semicircle. So from the external point, point A, we have tangent AO and tangent AQ. So from the common external point, point A, we have two tangents to this semicircle, AO and AQ. And according to rule number 2, that the lengths of two tangents from a common external point to a circle are equal, we get that AO equals to AQ, but AO is 10, therefore AQ must be also equal to 10 units in its length. In the next step, we extend side OB and side AM by a straight line until they touch each other. And we define the touching point of the extended side OB and AM as N. By doing this construction, we created here the right triangle, triangle AON. We define angle ANO as theta. And we focus on the right big triangle, triangle AON. On the right big triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. We'll focus on the right green triangle, triangle QPN. On the right green triangle, triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay. In the next step, we will prove that the green small triangle PQN, the green small right triangle PQN, is similar to the big right triangle, triangle AON. So write it down. We will prove that the big right triangle, triangle AON, is similar to the small right green triangle PQN. So, why the green triangle is similar to the big right triangle, triangle AON? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the big right triangle. And it is equal to this angle in the green small right triangle, that is actually angle PQN. Repeat again. Angle AON in the big right triangle AON is equal to angle PQN in the green small right triangle PQN. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. Angle theta is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. So if we relate to angle theta as it belongs to the big right triangle AON, it will be angle ANO. And it is equals to angle theta itself. If we relate to angle theta as it belongs to the green small triangle PQN, it will be angle PNQ. So repeat again. Angle ANO equals to angle ANO in the big triangle equals to angle PNQ in the small green triangle. This equation means that angle theta equals to itself. We just call to theta, to angle theta, two different names. Angle theta is a common angle that belongs to both triangles. So angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle OAN in the big triangle. And it is equal to this angle in the small triangle, small green triangle, that is actually angle NPQ. Repeat again. Angle OAN in the big triangle equals to angle APQ in the small green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the big right triangle AON are correspondingly equal to all the three angles in the small green triangle PQN. Therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down. The big triangle AON, the big triangle AON is similar, this is the sign of similar, to the small right green triangle PQN, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AO in the big right triangle over side QP in the small green triangle equals to side AN in the big triangle over side PN in the small green triangle, and it is also equals to side ON in the big triangle over side QN in the small triangle. Repeat again, we derive that AO over QP equals to AN over PN equals to ON over QN. Okay, so AO equals to 10 over QP equals to 5, and it is equals to AN. AN equals to AQ plus QN. So AN equals to AQ, that is 10 plus QN. So in total AN equals to 10 plus QN. Over PN. PN equals to PB plus BN. That is to say PN equals to PB, that is 5 plus BN. So in total PN equals to 5 plus BN. Repeat again. We found out that 10 over 5 equals to 10 plus QN over 5 plus BN, and it is equals to ON. ON equals to OB plus BN. OB is 5 plus 5 plus BN. So in total ON equals to 10 plus BN. Over QN. QN is the missing sign, so we leave it as it is. So in conclusion, we found out that 10 over 5 equals to 10 plus QN over 5 plus BN, and this equals to 10 plus BN over QN. 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and this equals to 10 plus BN over QN. So here those two expressions are equal to each other, so we get equation number 1 from those two expressions that are equal to each other. So according to equation number 1, we found out that 2 equals to 10 plus QN over 5 plus BN. But those two expressions are also equal to each other. So we get equation number 2 from those two expressions that are equal to each other. So actually, according to equation number 2, we get that 2 equals to 10 plus BN over QN. I copy again equation number 1. According to equation number 1, 2 equals to 10 plus QN over 5 plus BN. So we have here two equations. We'll multiply this equation number 1 by 5 plus bn, and we get that according to equation number 1, 2 times 5 plus bn equals to 10 plus qn. Here we will open the brackets on this side of this equation number 1, and we get that according to equation number 1, 2 times 5 is 10, plus 2 times bn equals to 10 plus qn. So here we have 10 on both sides of the equation, so 10 we get cancelled. What is left from equation number 1 after we cancel 10? In this side of the equation we have 2 times bn. On the other side of the equation we have it is equals to qn. We actually found out that according to equation number 1, qn equals to 2 times bn. When according to equation number 2, 2 equals to 10 plus bn times qn. Here we multiply this equation number 2 by qn, and we get that according to equation number 2, 2 times qn equals to 10 plus bn. Okay, so we have 2 times qn equals to 10 plus bn. Here we will substitute qn in this equation number 2 by 2 times bn, because qn equals to 2 times bn. We'll do it now. We get that 2 times qn, and qn is 2 times bn, and it is equals to 10 plus bn. 2 times 2bn is 4bn, so according to equation number 2, 4 times bn equals to 10 plus bn. Here we subtract from this equation number 2 bn, and get that according to equation number 2, 4 times bn minus bn is 3 times bn, that is equal to 10. So I shall found out that according to equation number 2, 3 times bn equals to 10. We divide this equation number 2 by 3, and we get that according to equation number 2, bn equals to 10 over 3 units. bn equals to 10 over 3 units. So I can write down in the original drawing that bn, this line segment bn, equals to 10 over 3 units in its length. According to equation number 1, qn equals to 2 times bn. That is to say, qn equals to 2 times bn, and bn is 10 over 3. So actually, according to equation number 1, qn equals to 2 times 10 over 3. 2 times 10 is 20, so this expression in total equals to 20 over 3. So actually found out that according to equation number 1, qn equals to 20 over 3 units in its length. So I can write down in the original drawing that qn, this line segment qn equals to 20 over 3 units in its length. Okay, so in the next step we'll complete this quarter circle to a circle. But before that, we will define qm as A. qm equals to A according to our definition. What is the length of mn? From the domain itself, it is very easy to see that mn equals to Qn minus Qm. Qn minus Qm. I repeat again. From the drawings it's very easy to see that Mn equals to Qn minus Qm. So Mn equals to Qn. Qn is 20 over 3 minus Qm. Qm equals to A according to our definition. So in total, Mn equals to 20 over 3 minus A. Okay, Mn equals to 20 over 3 minus A. Okay. In the next step, we'll complete this quarter circle to a circle. So completed the quarter circle to a circle, and we'll extend side BO by straight line until it touches the circle. We will define the touching point of the extended side BO with this circle as C. Point O is the center of the circle. Point C is the point on the circle itself. Therefore, OC is the radius of this circle. The radius of this circle equals to 10 units in its length. Why? Because of the fact that the radius of the quarter circle equals to 10 units. The radius of the semicircle must be equal to the radius of the quarter circle. Why? Because we just completed the quarter circle to a circle. Of course, they will have the same radius. So OC equals to 10 units. It's actually the radius of the quarter circle also. Okay. In the next step, I present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14, rule number 14 is true in any circle. So in any circle, if we draw two chords, AB and CD, from the common external point P, then the following equation is true, that PA times PB equals to PC times PD. So we have here a circle, and we have the common external point, point P. From point P, we drew two line segments towards this circle, line segment PB that cuts the circle at points A and B. In this way, we created chord AB. We have the second line segment from the same point, point P. From the common external point, point P. We have line segment PD that cuts the circle at points C and D. In this way, we created chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. Okay? We can actually implement rule number 14 in our drawing. Why? Because in our drawing, if we focus on the common external point, point N, from the common external point, point N is the common external point in relation to this circle. From the common external point, point N, we have two line segments that is drawn from point N. We have line segment NC that cuts the circle at points B and C. And we have also line segment NA that cuts the circle at points M and A. Therefore, all the requirements of rule number 14 are met, and for that reason we can implement rule number 14. So write it down. If we focus on the common external point N, according to rule number 14, NB times NC equals to NM times NA. Fit again, if we focus on the common external point N, according to rule number 14, NB times NC equals to NM times NA. NB is 10 over 3 times NC. What is the length of NC? NC in total will be equal to CO, that is 10, plus OB, that is 5, plus 5, that is also 10, plus BN, that is 10 over 3. So in total, CN equals to 10 plus 10, that is 20, plus 10 over 3. So NC equals to 20 plus 10 over 3. NC equals to 20 plus 10 over 3. And it is equals to NM. We already found out that NM equals to 20 over 3 minus A. Times NA. What is the length of NA? NA in total equals to NQ plus QN. That is to say, AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. AN equals to 10 plus 20 over 3. So we found out that according to rule number 14, 10 over 3 times 20 plus 10 over 3 equals to 20 over 3 minus 8 times 20 plus 10 over 3. So here it is 10 over 3, and here we multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. 20 times 3 is 60, and 60 plus 10 is 70, so in total in the numerator we have 70 over 3, in the denominator we have 3. And it is equals to, here we have 20 over 3 minus A. We multiply minus A by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. And we get that 20 A minus A times 3 is minus 3A. So in the numerator we have in total 20 minus 3A, and the denominator we have 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So 10 times 3 is 30, and 30 plus 20 is 50. So in the numerator in total we have 50 over 3. If we found out that 10 over 3 times 70 over 3 equals to 20 minus 3 over 3 times 50 over 3. So in both sides of the equation, in the denominator we have 3 times 3, that is 9. So we multiply this equation by 9 in order to cancel the denominator 9. And we get here, after we cancel 3 times 3, we have here only 10 times 70 is left in this side of the equation. In the other side of the equation we left only with 20 minus 3A times 50. Okay, we cancel the denominator on both sides of the equations. The denominator is 3 times 3, that is 9. Here we divide this equation by 10, and we get that 10 over 10 is 1, so here we left only with 70, and it is equals to 50 over 10 is 5. So it is 20 minus 3a times 5. So here we'll open the brackets on this side of the equation and we get that 70 equals to 20 times 5 is 100, minus 3a times 5 is minus 15a. So conclusion found out that 70 equals to 100 minus 15a. Here we'll subtract 70 from this equation and we'll get that 70 minus 70 is 0. That is equals to 100 minus 70 is 30 minus 15a. Here we'll add 15a to this equation and we get that 15a equals to 30. We divide this equation by 15 and finally we get that a equals to 30 over 15, that is 2. So here a equals to 2 units in its length. This line segment QN is equal to a equals to 2 units. Our mission is to find out the length of line segment AM that is equal to x. So x equals to AM, x equals to AM, this is AM, that is equal to x. And AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AM equals to AQ plus QM. AQ is 10 and QN is A. So in total x equals to AM equals to 10 plus A. So it is 10 plus A is 2. And 10 plus 2 is 12. In conclusion, we found out that x equals to AM equals to 12 units. So the length of line segment X, that is actually line segment AM, it is equals to 12 units. And that is the answer to the question. In the next step, I will summarize the lecture. In this lecture, we actually found out the length of this line segment AM, that is equal to x according to what is given as the question. So in the drawing, we have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have this semicircle. It's given as the question that AO equals to 10 units in its length. And our mission is to find out the length of this line segment AM that is equal to x. Okay, so first of all, because of the fact that AOB is a quarter circle, it means that this angle equals to 90 degrees and side AO equals to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore OB must be also equal to 10 units in its length. But OB is also the diameter of the semicircle. And we know that OB equals to 10, therefore the radius of the semicircle must be equal to 10 over 2, that is 5. So we define the center of this semicircle as P, and therefore OP, that is the radius of this semicircle, equals to 5 units in its length, and PB, that is also the radius of this semicircle, it is equal to 5 units in its length. Then we define the point of tendency of tangent AM with this semicircle as Q, and we join points P and Q together by certain. Point P is the center of the circle, point Q is the point on the circle itself, therefore PQ is the radius of the semicircle, that is equal to 5 units. We have the radius PQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 1. Then we focused on the common external point, point A. In relation to the semicircle, point A is an external point. From point A we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they must be equal to each other. That is to say, AO equals to AQ. But AO is 10, therefore AQ must be also equal to 10. Okay, in the next step, we extended side AQ and side OB by straight line until they touch each other. We define the touching point of the extended side OB and side AQ as N. By doing this construction, we created here the right big triangle, triangle AON. We define this angle, angle ANO, as theta. We focused on the right big triangle, triangle AON. In the right big triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees equals to 180 degrees. That is the sum of the angles in the triangle. Likewise, according to the same logic, if we focus on the green triangle, the green right triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta, according to the rule that the sum of the angles in the triangle is equal to 180 degrees. Okay, then we actually proved that the green small triangle PQN is similar to the big right triangle, triangle AON. Why? Those two right triangles are similar to each other. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, this is a common angle that belongs to both triangles. So we can write down that angle theta equals to itself. It's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually prove that all the three angles in the right triangle A1 are correspondingly equal to all the three angles in the right small triangle QPN. Therefore, we actually proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AO in the big right triangle over OP over QP in the small triangle equals to AN in the big triangle over PN in the small triangle equals to ON in the big triangle over QN in the small triangle. AO is 10, QP is 5, AN, what is the length of AN? AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10 plus QN. So in total, AN equals to 10 plus QN. AN equals to 10 plus QN over PN. What is the length of PN? PN equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. And so in total, PN equals to 5 plus BN. Here, PN equals to 5 plus BN, and it is equals to ON. What is the length of ON? In total, ON equals to OB plus BN. That is to say, ON equals to OB, that is 5 plus 5, that is 10, plus BN. So in total, ON equals to 10 plus BN. Here, ON equals to 10 plus BN over QN. QN is the missing sign, so we leave it as it is. So conclusion found out that 10 over 5 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. Those two expressions are equal to each other. In this way, therefore we created equation number 1 that says that those two expressions are equal to each other. That is to say, according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. Those two expressions are also equal to each other. In this way, we created the equation Number 2 that says that those two expressions are equal to each other. That is to say 2 equals to 10 plus bn over qn. It again, according to equation number 2, we actually found out that 2 equals to 10 plus bn over qn. Here we multiplied, by according to equation number 1, we actually found out that 2 equals to 10 plus qn over 5 plus bn. Here we multiplied this equation number 1 by 5 plus bn and found out that 2 times 5 plus bn equals to 10 plus qn. We opened the brackets on this side of equation number 1 and found out that 2 times 5 is 10 plus 2 times bn equals to 10 plus qn. Here we have 10 on both sides of the equation, so 10 will get cancelled. After we cancel 10, in this side of the equation number 1 we have to only with 2bn. In the other side of the equation number 1 we have to only with qn. So in conclusion, found out that according to equation number 1, qn equals to 2 times bn. Here we multiply this equation number 2 by qn and found out that 2 times qn equals to 10 plus bn. So 2 times qn equals to 10 plus bn according to equation number 2. Then we substitute qn in this equation number 2 by 2 times bn, because 2 times bn equals to qn. So 2 times qn, and qn is 2 times bn, equals to 10 plus bn. 2 times 2bn is 4bn, so 4bn equals to 10 plus bn. Here we subtracted bn from this equation number 2 and found out that 4 times bn minus bn is 3 times bn. So 3 times bn equals to 10. We divided this equation number 2 by 3 and finally found out that bn equals to 10 over 3. Here, this line segment bn equals to 10 over 3 units in its length. While according to equation number 2, we actually, according to equation number 1, we already found out that qn equals to 2 times bn. So qn equals to 2 times bn, and bn is 10 over 3, so qn equals to 2 times 10 over 3, 2 times 10 over 3 is 20 over 3. So in conclusion, found out that line segment qn, this line segment qn, it is equal to 20 over 3 units in its length. Okay? And then we found out the length of this line segment mn. From the domain itself, it is very easy to see that mn equals to qn minus qm. Again, mn equals to qn minus qm. qn is 20 over 3 and qm equals to a according to our definition. So in total, mn equals to 20 over 3 minus a. Here mn equals to 20 over 3 minus a. Then I presented to you rule number 14 and implemented rule number 14 in our drawing. According to rule number 14, in any circle, rule number 14 is true in any circle. So, in any circle, if you draw two chords A, B, and C, D from the common external point P, then the following equation will be true. That PA times PB equals to PC times CD. Again, PA times PB equals to PC times PD. So in the drawing we have the common external point A, from the common external point we have the common external point P. From the common external point P, we drew two line segments towards this circle. Line segment PB that cuts the circle at points A and B. In this way created called AB, and we have from the same common external point P, we have line segment PD that cuts the circle at point C and D. In this way we created line segment CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing we have, if we focus on the common external point N, if you focus on this common external point N, from the common external point N, we have two line segments towards the circle, line segment NA that cuts the circle at points M and A, and we have also line segment NC that cuts the circle at points B and C. Therefore, all the requirements of rule number 14 are met, And therefore we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again, according to rule number 14, if you focus on the common standpoint point N, NB times NC equals to NM times NA. NB is 10 over 3. NB is 10 over 3 times NC. Again, NB is 10 over 3. NC equals to 10 plus 10 plus 10 over 3. 10 plus 10 is 20, so in total NC equals to 20 plus 10 over 3. Again, NC equals to 20 plus 10 over 3, and it is equals to NM. NM, we have found out that NM equals to 20 over 3 minus A. Here, NM equals to 20 over 3 minus A times NA. What is the length of NA? NA equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. Here, AN equals to, here, AN is 10 plus 20 over 3. Again, AN equals to AQ, that is QN. AQ is 10 and QN is 20 over 3. So in total, AN equals to 10 plus 20 over 3. Repeat again, AN or NA equals to 10 plus 20 over 3. So in conclusion, we found out that 10 over 3 times 20 plus 10 over 3 equals to 20 over 3 minus A plus 10 plus 20 over 3. So it is 10 over 3 times, here we have 20 plus 10 over 3. We multiply 20 by 3 and then we divide it by 3 in order to make a common factor of 10 over 3. So here we have 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator we have 70 over 3. And it equals to 20 over 3 minus A. We multiplied minus A by 3 and then we divided by 3 in order to make a common factor of 20 over 3. So minus A times 3 is minus 3A, so in total in the numerator we have 20 minus 3A over 3 times we have 10 plus 20 over 3. We multiply 10 by 3 and then we divide it by 3 in order to account for 20 over 3. 10 times 3 is 30, 30 plus 20 is 50. So in total in the numerator we have 50 divided by 3. So in conclusion, we found out that 10 over 3 times 70 over 3 equals to 20 minus 3 over 3 times 50 over 3. We have in both sides of the equation, we have 3 times 3 in the denominator. That is to say, we have 9 in the denominator of both sides of the equation. Therefore, we multiply this equation by 9 in order to cancel the denominator 9. We multiplied by 9 and we found out that 10 times 70 equals to 20 minus 3a times 50. Then we divided this equation by 10. So here 10 over 10 is 1, so we're left only with 70 in this side of the equation, times 10 minus 3a times 50. And 50 over 10 is 5. So in total in this side of the equation we're left only with 20 minus 3a times 5. Here we open the brackets on this side of the equation and found out that 70 equals to 20 times 5 is 100 and minus 3a times 15 is minus 15a. So in conclusion found out that 70 equals to 100 minus 15a. Here we added to this equation, we subtracted from this equation 70. 70 minus 70 is 0 and 100 minus 70 is 30. So 30 minus 15a equals to 0. We added to this equation 15a and we found out that 15a equals to 30. Here we divided this equation by 2 and finally found out that a equals to 30 over 2 is 15. A equals to 2. So here this line segment QM is equal to A equals to 2. our mission is to find out the length of this line segment AM, that is x. So x equals to AM. Mission is to find out the length of line segment x that is equal to AM. But from the drawing it is very easy to see that AM equals to AQ plus QM. AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AQ is 10 and QM is A. Again, AQ is 10 and QM is A. So in total, x equals to AM equals to 10 plus A, and A equals to 2. Therefore, x equals to AM equals to 10 plus A, it is 10 plus 2. So in total, x is equal to AM equals to 12 units in its length. Here, and fit again, answer to the question is that line segment AM that is equal to x, it is equal to 12 units in its length. Okay, thank you very much.